Hi everyone. This is the solution discussion for NSEM paper of science, and it consists of 7 questions. So let's get started. First question states data science is a multidisciplinary field that integrates concepts of from various domains such as computer science, statistics, machine learning, and data analysis. With this in mind, we have to explain firstly two primary paradigms of data research, that is hypothesis driven and data driven. And next point, we have to discuss about that we have to describe different types of data commonly encountered in data science, that are structured, unstructured, quantitative, categorical, and big data. And third part is to identify and explain at least three common formats of data and discuss their relevance to data science. So let's get started. First part was to explain two primary paradigms, that is hypothesis driven and data driven. So firstly, hypothesis, what happens is in data research, it can be approached through two primary paradigms, that is hypothesis driven and data driven. And in hypothesis, the researcher starts with a specific hypothesis or assumption based on prior knowledge or existing theories, and the goal is to collect data that will either confirm or refute its hypothesis. What are the steps for it? So formulate a hypothesis that students who study daily to score higher on exams. Secondly, collect data of them, and then third, analyze the data to confirm the reject hypothesis. Now consider example that a pharmaceutical company hypothesizes a new drug and then reduces to reduce the blood pressure, and then they conduct an experiment to test that assumption. So this is the one example. Consider another example where a researcher might hypothesize that students who actually study for 2 hours a day will have higher exam scores. So, to test this, they might collect data on the student study habits and exam scores and then analyze the relationship between two variables. So, what will be the process? The process will be firstly formulate the hypothesis, that is, for example, exercise improves mental health, and then collect data to test the hypothesis. Third is analyze the data to confirm or reject the hypothesis. The next data research is data driven paradigm. So in contrast to this hypothesis driven, data driven paradigm begins with the raw data, or and the goal is to find patterns, relationship, or insights without any pre-convinced hypothesis. That analysis may uncover new trends or insights based on what it was previously unknown. What are the steps for it? So firstly, we collect large amount of data from different sources. Then we use many techniques or algorithms and statistical techniques to find the patterns. And third is to formulate conclusions based on the observed trends. uh, Now, consider an example that a company analyzing customer purchase patterns that might uncover that customers who buys product A and B together also buys product C. This insight could inform marketing strategies without having any initial hypothesis about it. Another example mentioned in the document is consider an e-commerce company that analyzes the customer purchase. For example, if one person buys beauty products, it is noticed that he might buy clothing also. So this is how data driven paradigm works. And the B part talks about the types of data science. That is, the data science deals with various type of data. So firstly is structured data. That is highly organized data that is often stored in rows and columns such as relational databases. It is easy to search and analyze. For example, a spreadsheet containing customer names, their age and address. Next on, we have unstructured data. This type of data is not organized in predefined way, making it harder to process using traditional tools. So here are the examples such as a social media post or any audio recordings comes under unstructured data. Moving on, we have categorical data that represents categories or groups without numeric meaning. For example, types of animals such as a cat, dogs, or customer satisfaction, such as the customer is satisfied, neutral, or dissatisfied. About quantitative data, so it refers to the numerical values that represent quantities. It is measurable and can be analyzed by using a statistical method. Uh, Example for quantitative data is the height of students from ranging from 160 to 170, or the temperature in a city recorded as 25 degree, or the income of person is 50,000 rupees. Moving on, the C part talks about the identify and explain at least three common sources or formats for data and discuss their relevance in the science application. So, firstly, we have web data. Web data is the data collected from websites that includes click streams, user behavior, user interaction, and the data is crucial for understanding performance, improving web designs, and creating recommendation system. Next on, we have sensor data, that is the data generated by IoT devices such as sensors, or temperature readings or GPS coordination. So it's relevant, it is crucial for smart cities or health monitoring system and automated vehicles or automated any type of mechanism. Next on, we have survey data, that the data is collected through surveys, questionnaires, or the interviews to capture opinions or attitudes or behavior. Relevance, it is used in market research, public health, and studies, and customer satisfaction analysis. Lastly, we have log data. No, I think it's the yeah. So log data that automatically records the data from systems such as server records or app usage logs. Relevance, it is important for debugging, security monitoring, and understanding the system performance. So this was the first question. Let's move to a second question, which was again for 10 marks. The question states, firstly, what is data imputation and how we can decide best imputation method for handling missing values. Then we have to discuss potential risk in using mean value and methods to explain the nearest neighbors of imputation. So, firstly, what is data imputation? So, data imputation refers to the process of replacing missing or incomplete values in a data set with substituted values that makes a data set ready for analysis and modeling. This is important because missing data can skew analysis and lead to inaccurate result. Imputation helps to prevent data loss, ensuring that the models and analysis can proceed efficiently. Now, how do we decide on the best imputation model? So, the choosing of the best imputation method depends upon several factors, and these are, firstly, nature of data, percentage of missing values, underlying distribution, and impact on analysis. So, about nature of data, so we need to check whether the data is numerical or categorical, with and how it will influence the choice of imputation method. Numerical data might use method or and I have one more thing. Yeah, so percentage of missing values. So for data sets with very few missing values, we use simple methods like mean, median, and suffice. And for data sets with large number of missing values, we use advanced models like nearest neighbors or regression-based imputations. Next on, we have underlying distribution for data. That is, if the data is skewed, we use the median or mode, and may be preferable over the mean, as the mean can be distorted by extreme values. Now, impact on analysis. So, the imputation model should be chosen carefully to minimize its effect on accuracy of model and conclusions drawn from data. For instance, simple method might be quicker but less accurate in preserving the data's original circle. The risk of using a mean value method. So, mean value method involves replacing missing values with average values of variables. While it is easy to implement, but it comes with following a risk. For the first is loss of variance, that is replacing missing values with mean reduces variability in data that can lead to data set less represented of the true population. Next on, we have biasness, that is it can use the mean we can use mean to introduce bias, especially if the data is not symmetrically distributed, and this can lead to misleading conclusions. And lastly, we have distorted relationship, that talks about imputing the mean values for missing data can weaken the relationships or correlation behaviors, but correlation between variables, which may affect the predictive models. Now, how nearest neighbor imputation works. So, nearest neighbor imputation, that is KNN, is an advanced method that estimates missing values based on values of similar observation. The steps it includes is, firstly, we have select feature that identifies which feature will be used, find nearest neighbor for data point with missing values, find k nearest neighbors on choosing distance. For example, we have Euclidean distance. Then third is estimating missing values, that is they are imputed as the average or weighted average. Now, example. So, suppose we have a data set where math score for a student is missing. So, the KNN method looks at the each student features and find the K closest based on this structure. Then, the missing math score is filled in as the average of those students of math score. Now, advantages of nearest neighbor imputation. Firstly, it preserves relationship between variables. Secondly, it can handle both numerical and categorical data. Third, it adapts to the data patterns and improves its accuracy. Now, moving on to the third question, that states explain the concept of linear regression and how the best fit line is determined, and write the algorithm for regression for the given input data points x and y. So, guys, you will be provided this Google document in the caption of this video. So do check it out once, and let's talk about the concept of linear regression. Okay. So, concept of linear regression. So, linear regression is a statistical method that is used to model the relationship between the dependent and independent variables. So here, consider a simple line equation, that is y is equals to mx plus c, that is y stands for y-axis values, then x is the x element, c is the intercept, and m is the slope of the line. I think I need to correct this, might be some error. And then the goal of linear regression is to find the values of slope and intercept that minimize the error between the predicted and actual values. Now, how the best fit line is determined? It is determined by using least square methods. There are other methods to it also, but we are considering least square method as it is mentioned in our question. So, it minimizes the sum of squared errors, that is SSE, between actual and predicted values. So we have predicted formula, that is y cap of I is equals to m into xi plus c. Then we have error calculation, that is yi minus the predicted y value. Then we have objective, that is sum of square errors, the SSE is equals to summation of yi minus summation minus of predicted value. And then we have optimal scope slope and intercept that uses calculus and optimal values for slope and c, and they are derived as this yeah, this is our formula for it. And next on we have algorithm for linear regression that okay, algorithm for linear regression, that is input data points. Consider it has x from x, that has a series from x1 x2 to till xn. Then we have y from y1 to yn, and the output is a slope m, intercept c, and best line fitted an equation y is equals to mx plus c. Now, the calculation of means is the compute the mean of x, that is x bar is equals to xi by xn. It is all the sum of them. Then mean of y is the sum of y values divided by n. Then we have compute slope m, that is the formula for this, that is summation of minus 1 and then summation of that of whole square. And then the compute intercept, that is c, will use the formula that c is equals to y minus x plus mx, minus mx, sorry. And then make predictions for any new values of x. Predicted y is using y is equals to mx plus c, and then evaluating the model, which compute matrices like r squared. This is how it is defined. And then example the points that we have, this point and then means and slope of it and intercept and best fitted line. Now, let's talk about what is k nearest neighbor algorithm, how does it work, and in the context of classifying based on distance, and how the distance of how the choice of the parameter affected by k will affect the model's uh, performance. So let's get started. Firstly, what is KNN? That is K nearest algorithm. So KNN is the algorithm that is a simple non-parametric machine learning algorithm that is used for classification and regression task. It works by identifying the k nearest data points to give the data input data point based on metric predicting the values. And then we have another output based majority class and on the average of those network. Now, how does KNN works? Firstly, choosing the value for k, that is first step is select a value of k that chooses randomly. Now, common choices k is equals, keep k is equals to 3, 5 or 7, and then use the distance matrix, that is KNN relies on distance matrix that calculates how close two data points are. That is the most common distance between the Euclidean distance. But other distance like Minkowski distance can also be used depending on the problem. So here is your our Euclidean formula, and we need to identify k nearest point, and then we have to perform classification, that is count the number of data points for each k neighbors, and then assign the process to the majority vote. Now consider this is our data, and then we have our query point, and then k is equals to 3. Now we have to calculate the distance for point 1, point 2, point 3, point 4, and these are the values given here using the Euclidean formula. Then we have identified the nearest neighbors, and then plotting it and classifying query. So predicted class was b, like predicted with all the points, and then we have classified it. Fifth question is explain the key difference between k-mean clustering and hierarchical clustering, and what are the advantages of it, and what are how we can and what are the hierarchical level and we visualize it. Okay. So k-mean clustering. So k-mean clustering is a definition. So these are partitioning algorithm that divides KKK, that is divides K cluster based on centroid proximity, requires predefining numbers of cluster, flat clustering, iterative, and uses Euclidean distance by centroid, and they are scalable. That is, it works well with the large data set. It is expensive for large data set, and cluster example, that is, it assumes the cluster are spherical and of equal sizes, whereas this captures complex cluster due to flexibility. And output of that, it has direct cluster assessment, and it has a dendrogram that shows this. So I just want to show you how direct cluster looks like and how a dendrogram looks like. So direct cluster is similar to what we know, and